Hello students, this is Shakil, and today we're going to discuss something from AS Physics, and that is work, power and energy. And this is the video lecture one, and we will be covering energy conservation, having the main topics as work, conservation of energy and different types, efficiency, and then power, and then some forms of power. So mainly this video lecture is based on your knowledge of O levels or IGCSE physics knowledge. So first we have to talk about work. Work is the product of applied force, and this is moved along the line of action of force. The line of action of force here is the key word. You have to include that in the definition. So this definition is exactly similar to the definition of the IGCSE, the definition of the work in IGCSE. So its equation is work equals component of force along the distance direction into distance. Well, let's talk about this component of force along distance. Let's say there is a box, and what we're going to do is we're going to apply a force F on it, which is making an angle theta with the direction of the distance. So, well, we have to see that what is the component of force that is along the distance. So for that, we have to resolve this force. And you know that the component adjacent to theta is cosine. So this is F cos theta, which is along the direction of the distance. So that's why we say work equals F cos theta into D. So work equal F D cos theta, where D or S is actually the distance. And you know when we are moving along the straight line, so distance and displacement both have same meaning. And theta is the angle between this force and the distance, like the actual force and the distance. About the unit, well, that's the unit is joule. 1 joule equals 1 Newton meter, and the most common definition. 1 joule is the work done when 1 Newton of force moves an object 1 meter in its direction. Well, you have to remember that work is a scalar quantity, it's not vector. There are 3 types of work. Well, the first type is the maximum positive work, and this is based on actually the angle. This is on the basis of angle between force and distance. Okay, so the first one is maximum positive work. This happens when force and distance are exactly in the same direction. It means the angle between them is 0. And you put theta 0, so you know cos 0 is 1. So that's why you got answer. You got this answer, which is W equal plus FD. Well, it means this is the maximum work that you can get. And the features of this work is object gains some energy. Well, this energy can be either kinetic or potential. About the second type is maximum negative work. This happens when, let's say, something is moving in this direction and you have to stop it. So you apply force, braking force, and after covering some distance, it comes to rest. Well, and during this phase, it covers S distance. So we say that the friction is in this direction and distance is in opposite direction. So the angle between them is 180 degree. So that's the case when force and distance are in opposite direction. Cos 180 is -1. So that's W equal minus FD. This is maximum negative work. And the feature is that the object is going to lose its energy. The third type is perpendicular force work done. Well, there are many occasions in which object is moving along a circular track. So let's say this is an object which is moving along anti-clockwise direction. Well, this object is of mass m. At any instant, its direction of motion is always along the tangent, and force is towards the center. So this force is known as perpendicular force because the angle between force and its velocity is 90 degree. So cos 90 is 0, which means work is 0. It means that the perpendicular force can only change direction of moving objects. It does not do any work. That's why work done due to perpendicular force is always 0. Well, we have to discuss the work done in terms of types of forces. Well, You can apply two types of force. The first force is a constant force. It means that you're not changing its value is remaining the same. Let's say if you're applying 20 Newton and it is staying the same throughout the motion. So we say that, okay, this is the constant force that you're applying. So in order to find the work done due to constant force, we use W equal Ft cos theta. For a variable force, let's say you started with 50 Newton and then you switch to 40 Newton, you switch to 45 Newton, you switch to 20 Newton. It means that you keep on changing the force. So that's why we say this is a variable force. So when force is changing, either uniformly or non-uniformly, you have to find the work done using the area under force distance graph. So while you plot force along y-axis, distance along x-axis, and then the graph is there. This graph, first graph is A. It shows that the force is uniformly changing, and the force, this is graph B, which shows that force is non-uniformly changing. So in both of them, area under the force distance graph gives you work done, because area is product of y and x-axis. So if y is F and x is D, so F into D is work. So that's why area under FT graph gives you work done, but you'll use only when the force is changing. Okay, if the force is constantly changing, like uniformly changing, like first it was 0 Newton, then it was 10 Newton, then it is 20 Newton, then it is 30 Newton, then it is 40 Newton. This means that the force is uniformly changing. So then you use average force into distance. So average force is like minimum force. Minimum force in many cases is 0. And then minimum force plus maximum force divided by 2 into distance. So as minimum force in most cases is 0, so we say that work is half of maximum force into distance, or you can use area under force distance graph. Okay, so let's get out of the work and let's move into the energy. Well, energy is a great thing. Everything depends on energy. Our life cycle is actually dependent on some energy that we're using. And in this universe, when it was created, a constant amount of energy was there. And right now, till the creation of universe to this date, we have same amount of energy, and we are actually recycling or reusing the same energy that has provided to the universe. So what is ability? What is energy? It's the ability of object to do some work. It is a scalar quantity, and its SI unit is same as work, that is joule. Well, there's important principle, work energy principle. This relates work and energy with each other. So we say that work done on an object is equal to change in energy of object. Like if you do work on an object in order to move it, that will be stored in the form of energy inside the object. Or if some energy is being changed, then then when energy is being changed, then work is being done on the object. Like if the car is moving, then chemical energy is changing into kinetic energy, and that's why some force by engine is exerted on the car and it covers some distance. Well, let's look on a famous principle, that is principle of conservation of energy. Well, this is actually our life is all about. Energy can neither be created nor destroyed. It can only changes from one form to another form, while total amount always remains conserved. Well, we have to see that how we can apply law of conservation of energy in some practical situations. So for that, we have to make ourselves familiar with some common energy types. The first one is chemical energy. Well, chemical energy is the energy stored in atoms or molecules. For example, living things, human, animals, plants, fuel, food, cells, batteries have chemical energy in them. Internal energy is generated by U. It is sum of kinetic energy and potential energy of molecules in a substance. Let's say if there is a substance, there is a liquid, and some molecules, of course, are there. The molecules are also moving, so they are having kinetic energy, and they are attached with each other through some bonding, so they are having potential energy. So if you add kinetic energy and potential energy of molecules in a substance, you get internal energy. Okay, thermal or heat energy, well, it's the most common one. The energy related to sum of kinetic energies of molecules in a substance is known as thermal energy. Well, there are some useful energies, the energies that are required in a process. We want that energies to be there, like kinetic energy, potential energy, and electric energy. These are useful. Wasted energies, these are the unwanted energies that during a process that we don't want to be there. Let's say thermal energy and sound when you are braking a car. Well, there's a famous relation between all the energy types. Input energy is equal to useful output energy plus wasted energy. Input energy is the one which is available at the start of the process, and this decreases with the time. Useful output energy is available at the end or during the process, and actually it increases during the process. Wasted energy, well, this energy is not required, but this is going to be produced during energy cycle. We have to talk about efficiency now. This would be similar as you have done in your IGCSE O level. It is the ratio of useful output to total input. And efficiency is usually having two equations, one without percentage and one in percentage. So efficiency is useful output over total input, and its answer is always less than 1. Well, the ideal system is having an efficiency of 1 only. For that, the system should be ideal. Ideal means that there is no energy loss. For percentage efficiency, it is useful output over total input multiplied by 100%. And again, the percentage efficiency can never exceed 100%. Okay. Well, power is actually the rate of work done or rate of energy conversion. It's quite simple. And its equation is work over time or energy over time. And its SI unit is watt, and 1 watt equals 1 joule per second. And 1 watt is amount of power when 1 joule of work is done in 1 second. And power is a scalar quantity. Well, there are some types of power. The first one is mechanical power, the power which involves some mechanics, which is like work over time and energy over time. For the second one, it is motive power, power associated with moving objects. So we have to derive some expression for this. Since power is work over time, and we know that work is force into distance. And one more thing is this distance over time is equivalent to speed or velocity. So we say that power equals force into velocity. So this is the expression for motive power. The next one is electrical power. Electrical power is usually associated with the electrical objects. So power is I into V. P is electrical power measured in watts, and I is the current, which is in ampere. V is the voltage or potential difference or EMF measured in volts. We have to derive this. So, you know, power is work over time, and we know the definition of potential difference, which is work done per unit charge. So from this, you can make work as the subject, which is Q times V. So now what we'll be doing is we'll be putting this value over here at place of work. So this power would be equivalent to QV by T. And if you look on QT, you know, Q by T is current. It is rate of flow of charge. Q is charge. This Q is charge. And this T is time. So we say that P is I into V. So this is the derivation for the electrical power. Okay, so then we have to do the graphical analysis of the power. It's quite simple. Mechanical power is work over time or energy over time. So if you plot a graph between work and time, and then you have let's say you have a straight line. So if you find the gradient, well, that gradient gives you the power because work over time is power. And then if you plot velocity with force, and well, if you find the area of force velocity graph, you get the average power because the motive power is force into velocity, and you know the area is y into x. So along y-axis is force, and along x-axis, oh well, it's the other way actually. Along y-axis is velocity, and along x-axis is force. So that's why area gives you average power. So let's look upon some past paper questions for work, energy conservation, power, and efficiency. Well, the first ones are the few MCQs. The first one is related to principle of conservation of energy, which says that which statement best represents the principle of conservation of energy? Well, let's see. It's about the definition. Energy cannot be used faster than it is created. No. The supply of energy is limited, so energy must be conserved. No. The total energy in a closed system is constant. Yes. In a closed system means that energy is changing its form in the same system. Seems to be correct. D, the total energy input to the system is equal to useful output energy. Well, is it correct? Input energy equals useful output? No, thus wasted is also there. So it means this is incorrect as well. So C is the correct option. Okay, let's look on number 2. A crane is being used to lift a container off a ship. One container has a mass of 14,000 kilogram and is being lifted vertically with a speed of 3.2. And when they say this speed, it means it is the constant speed. The electrical motor being used to supply the power to lift the container is using a current of 240 ampere with a potential difference of 2200 volt. What is the efficiency of the system? Well, this is about efficiency. So as all the answers are given in percentage, so we say that percentage efficiency is output power over input power into 100. Okay, so now we have to see what is the output power. Sorry, output power is actually motive power, which is product of force and velocity, and input power is actually the electrical power, which is product of current and voltage. So if an object is being lifted upward with constant speed, it means the force is equivalent to its weight. Weight into velocity over current into voltage. So now you have to put all the values. Weight is like 14,000 into 9.81. So this is weight, and velocity is 3.2 divided by current is 240 and voltage are 2200. So that's how you can get the answer. Okay, let's look on the next question. Well, the data below are taken from a test of petrol engine for a motor car. Power output of the engine is 150 kilowatts. Let's say this is the engine and the output is 150 kilowatt. The fuel consumption is 20 liters per hour. Oh, we're talking about input. And energy content of fuel is 40 megajoule per liter. Well, it means in 1 hour, 20 liters are consumed, and then the energy is 40 megajoule. So it means that in 1 hour, the total energy that is being consumed is 800 megajoule. And as the output is in the form of power, so we have to represent the input in the form of power as well, and that is like energy over time. So 800 mega is like 10 power 6 over time is 1 hour, which is like in 1 hour 60 minutes and 60 seconds. So you have to find the power then. So let me calculate it. So it is like 800 divided by 3600, and well, that is 2.22 into 10 power 5 watt. So if you convert it into kilowatt, so 2.22 into 10 power 2 kilowatt, or you can say 222 kilowatt. So it means that the output, you have to find output over input power. So output is how much? 150 kilowatt and input is how much? 222 kilowatt. So it means that you'll divide them. 150 divided by 222. So the answer is, well, actually, you don't have to do that. You just have to look for the options. So the option is, well, yeah, this seems to be correct because the output is 150 kilowatt, and the input is like, we have calculated it, 800 megajoules. So 40 into 20 is 800 into 10 to the power 6, and then multiplied by time. No, it's divided by time. So A is not the option. Well, B is the option, because you have to divide it now. Like if I write it over here, the input energy is energy over time. So it is 150 into 10 power 3, and energy is 40 into 10 power 6 into 20 divided by 60 into 60. And then this 60 into 60 will go upstairs. So it will be 150 into 10 power 3 into 60 into 60 over 40 into 10 to the power 6 into 20. So all these calculations are useless because we didn't look at the expression. So this expression resembles to B. So B is the correct answer. Okay, let's work out on this question. Leonardo Vinci proposed a flying machine that would work like a screw to lift the pilot into the air. The screw is rotated by the pilot. The machine and the pilot together have a total mass of 120 kilogram. Which useful output power must pilot provide to move vertically upwards at constant speed of 2.5? Okay, so power is, as this is motive power because the machine is moving, so force into velocity, and when anything is moving at constant speed, so the force should be equivalent to the weight. So the weight is like 120 into 9.81, and velocity is 2.5. So you'll get the answer over here. So the answer is like, let me see, what's the answer? 120 into 9.81 into 2.5. So that is 2943. Power is 2943. That is 2900 watt. So it means it is option D over there. So let's look at the last question. This is from the theory. A skier is pulled along horizontal ground by wire attached to the kite. This is the kite and the wire is attached, and the force of tension is 140, angle is 30 degree with the horizontal axis, and the speed with which the air is moving is 4.4 meter per second. The skier moves in the straight line along the ground with a constant speed of 4.4. The wire is at an angle of 30 degree to the horizontal. The tension is 140 Newton in the rope. Calculate the work done by the tension to move the skier for a time of 30 seconds. So you have to find the work done. Okay. So, well, work is F d cos theta. So how much is F? Well, F is of course 140. How much is the distance? Well, for distance, speed is distance over time, and distance is speed into time. So for distance, we'll be writing speed into time, and the angle is 30 degrees. Over here, how much is speed? 4.4. How much is time? 30 seconds, and then cos 30. So you'll do the calculation. You get the answer. 140 into 4.4 into 30 into 0.866. That is, well, quite a big number. Yeah, it's 16,000. So 16,000 joule is the answer. So thank you, students. That was the part one. The next video lecture will be about the energy types and calculations. like potential energy, kinetic energy, strain energy, and their convergence. So thank you so much, students. Take care.